Now that we've learned about GCFs and of both just numbers and also polynomials, we're going to learn how to factor by GCF. So we're going to pull out the factor, the greatest common factor that a binomial or trinomial or polynomial has in common. First, to warm up, try these two problems. Pause the video, multiply these out, and then click play again to hear the answers. So remember when we multiply, we're distributing this 2x squared. We would have 2x squared times 3x, which is going to give me a 6x cubed, and then minus 18x squared. On the second one, I want you to remember that you're going to distribute this 4x to both terms. So you could rewrite it if you wanted to, like 4x times 9x squared minus 5. And then you're going to distribute this negative 1 to both terms, and you have to take that negative with it. So it's going to be plus a negative 1 times 9x squared minus 5. We're going to come back to this idea later today in the notes, so please look at that. See, this is just another way to distribute, and now you would distribute to each one. We would have 36x cubed minus 20x minus 9x squared plus 5. Combine your like terms. We don't have any. Just put it in standard form. 36x cubed minus 9x squared minus 20x plus 5. Again, guys, we're going to come back to this idea here. So we don't normally show this step, but when you FOIL or when you distribute, you double distribute, you're giving this 4x to that binomial, and then you're giving this minus 1 to that same binomial. Notice the repetition. So another way to write this line means the same as our starting problem. That's what we're going to do today in class. Before we do that, first we want to just factor each polynomial by pulling out the GCF. Think of the GCF as dividing. We're going to divide something out and put it on the outside. So, for A, this is your answer. This is after you distribute it. I want to know, what did you distribute to each term? What's the greatest thing that you could have distributed to each term? So when you look at this, determine your GCF. 5 and 9. Well, 5 is prime, so our GCF is not going to involve a number, or the highest number would be 1. And then b and b squared, so our GCF is b. Basically, guys, divide each term by b. Put that b on the outside. If I take a b out of 5b, I would have 5. If I take a b out of 9b squared, I have a plus 9b. There's your factorization. To check it, think about distributing this. If you distribute, will you get 5b plus 9b squared? Will I get back to what I started with? Yes, I would. So here's your answer. That's how you can check it. I always suggest checking, but it's up to you to make the decision. Try B. Look at all three terms. What can I divide out or take out of all three? Basically, what is your GCF? All of them, look at the numbers first. And I will say with the GCF, you normally want to make the leading coefficient positive. So in this case, the leading coefficient is already positive. Let's keep it positive. We wouldn't want to divide out a negative and then leave it with a negative. All three of them can take out a 4. All three of them can also take out an x. So your GCF is 4x. Put that on the outside and undistribute it. Think of what you would have had there. 4x times what would give me an 8x cubed? That would be 2x squared. So you can think about the multiplication, or you can do the division. 8 divided by 4 is 2. X cubed divided by x is x squared. Next one, we have a minus 1x. And then we have a minus 4. Again, if you want to check it, negative 4x squared, negative 16x, you can check it. You can check it in your head or you can check it on paper, but I do suggest that you check it. Here's your final answer, so please circle that for me. Last one, guys, for C, GCF. Again, let's try to make that leading coefficient positive. So what can we take out of both of these? We can take out a negative 2x cubed. When you take that out, it's not going to disappear. You're going to put that on the outside and basically think about, what did I distribute to get that negative 14x to the 5th. Negative 14 divided by negative 2 is a positive 7. X to the 5th over x cubed is x squared. Negative divided by negative is a positive 6, and there's no x's on the inside. All right, that looks good. We can check it. This would be negative 14 x to the 5th, and then this would be negative 12 x cubed. Very good. So this is going to be our first method for factoring. We are always going to look for a GCF first. You may not always have one, but we will use this method in front of the other methods that we learned later on. Sometimes there's not always a GCF for the entire polynomial, and you may be able to factor a polynomial by grouping, and that means you're going to find a GCF for 2 of the terms. So if you didn't print the note guide, write this down. You can abbreviate it, but you want to make sure you know that. You would be grouping, which is finding a GCF for 2 groups of binomials when you have 4 terms. You may end up with a common binomial factor. This is going to look like that warm-up where I started, so glance back at that. These first 2 are actually kind of started for you. The next ones will really be where we factor by grouping. But the step is done here. See, I want to know basically another way that I can write this that would be a little shorter, that would mean the same thing. Notice the repetition. Let's go back to the warm-up. When we wrote this out, we took 4x times the binomial, here's that binomial, and then we took a minus 1 times the binomial. Notice it's the same binomial. So these terms in front can be put together in your starting binomial right here. So notice that it's x plus 2. What's another way I could write this distributing? Basically, what did I distribute to my x plus 2, guys? I distributed my 5, and I distributed my plus 3x. Let's try this. Let's check this and see if this is, in fact, a factorization. If we FOIL this out, 5x plus 10, notice, isn't that what I would have got here? 5x plus 10, and then plus 3x squared. Here's my 3x squared term, and my last one should be plus 6x. Yep. So it does, in fact, work. Your factorization is only this part. The 5 plus 3x, x plus 2. The rest of that work is me checking that it did work out. Notice the binomials match. So write that down. You can only do this if the binomials are the same. And I want you to visualize undistributing. Visualize undistributing, okay? Try this next one for b. Notice your binomials match again. B squared plus 1, B squared plus 1. So I can, instead of writing that twice, write that once. But what did I distribute to that B squared plus 1? I distributed 2 things. What is in front of those binomials? What's in front of there? That's what you need to remember. Is it just negative 2b? Is there nothing in front of there? Well, we have to be giving something to it. So what's in front of that binomial if nothing's written? It's a 1. So we would have negative 2b plus 1 being distributed. That's going to be where some people will make a little mistake, so watch that. And let's try it without. If you just tried to give the negative 2b to the b squared plus 1, would that be the same thing as your starting problem? That would only be the first product. How do you get the second product? We need to have something there. You have a plus 1 so that you will keep that product in your answer. All right? So this was a step already done for you. Let's look at the next 3. The next 3 now are going to be the starting polynomial with 4 terms where you need to group, pull out a GCF, and hopefully the binomials match so you can factor it down all the way. You are allowed to reorder these terms if you would like. So you can reorder if you would like. Write that down. So what you're going to do when you start with a polynomial of 4 terms, you're going to group the terms. Group the first 2, group the second 2, rewrite them in any order, whatever you want, but you're trying to group them. I normally just group them in this order first, and then if that doesn't work, I'll try a different order just to check. So I'm going to rewrite this grouped with these 2. I like a plus sign always in between, and then these 2. Pull out a GCF for the first 2. What is your GCF of the first binomial? They can both have a 2 divided out, and they can both have an h cubed divided out. So take out that 2h cubed, and what would you have left on the inside? You would have 3h minus 2. So notice how we divided that GCF out. I didn't make it go away, it just went on the outside. I undistributed. Now look at your next binomial. Determine a GCF for this one. 12h and negative 8. I could pull out a 4. And what will I have left when I divide out a 4? I will have 3h minus 2. Take a look at this, guys. Ding, 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 we have a winner. Look here. They match. So this is the same as 3h minus 2 times what binomial? All you do is take the terms that are in front, and that's your other binomial. So it's 2h cubed plus 4. You can check these, distribute it out. 2h cubed times 3h will give me 6h to the 4th. 2h cubed minus 2 will give me negative 4h cubed. 4 times 3h will give me 12h. And 4 times a negative 2 will give me a minus 8. There's my check. Okay, try the next one. So again, you can reorder if you want to try, but I would always try the problem first as is and then reorder if you need to. Group the first 2, group the second 2. Try pulling out a GCF, okay? So what can I take out of these first 2? I can take out a 5y cubed. If you divide out a 5y cubed, what are you going to have left? Y minus 3, and the y's are gone. In the second binomial, I can take out a positive y. You need to keep that plus sign, so that doesn't go away. And then I have y minus 3 left on the inside. Notice they match. This is called factoring by grouping. If the polynomial if you are going to be able to factor the polynomial by grouping, the polynomials will have to match. And we normally start with 4 terms for factoring by grouping. So I would have y minus cubed only written once. This is the same. These 2 lines are the same. Y minus cubed is being times by or multiplied by 5y cubed plus y. Now take a look at your answer there. Is this problem all the way done? Or do we actually have a GCF of your GCFs? We put the GCFs together in this first binomial. Is there something you can pull out of that? Yes. So you always look for a GCF. Beginning and end. You see, if we look back at the very beginning, if our first step was to look for a GCF, I could see that I could pull out a y from everything at the beginning and put that on the outside. It doesn't matter whether you do it at the beginning or the end. What does matter is that you do it, okay? So I can see now that I can pull a GCF out of here. I can take out a y. I'm going to put that y on the outside, and I have 5y squared plus y divided by 1 doesn't just leave nothing. Anything divided by itself leaves 1. Besides 0. All right, so there's our complete factorization. When you look in here, there's no other GCFs. When you look in here, there's no other GCFs. Pause the video, try C on your own, then play it out for me. All right, for this one, I'm going to group the first 2 and the second 2. In the first one, I can pull out a negative 3x squared, and I have x minus 2. The second one, I'm going to pull out a 4, and I have x minus 7. They don't match. So I could try reordering them if I want. Maybe I do a negative 3x cubed plus 4x, and then a minus 6x squared minus 28. Try it again just to see. I would group these two. I'd make this a plus, a negative. Group those two. I could pull out an x here, and I would have negative 3x squared plus 4. And then I would pull out a 2 there, and I would have negative 3x squared minus 14. They do not match. This tells you it is not factorable. So you didn't do anything wrong. It just is not factorable. All right, guys, you're going to take a look at the quick check on blended schools.